Okay, this is a quick summary video on y-intercept form or slope-intercept form. We're going to look at it quickly and do a few examples. First, to see that this is the y-intercept, the y equals mx plus b. The b part is the y-intercept. Just plug in x equals 0. If x equals 0, then this first term, 2 times 0 is 0, and we get minus 4, which is the second term. So y equals minus 4. So if x equals 0, we have the y-intercept negative 4 just staring at us. We could have seen it at the very beginning. When we plug in x equals 1, we get 2 times 1 minus 4. 2 minus 4 is negative 2. We plug in x equals 2. 2 times 2 minus 4 is 0. We plug in x equals 3. 2 times 3 minus 4 is 6 minus 4, which is 2. So as we move along the x-axis, 0, 1, 2, 3, we're noticing that we went from minus 4 to minus 2 to 0 to 2. We're basically adding 2 every step of the way. So we move over 1, we move up 2. So the slope is 2. So when we look at this equation, we can see, oh, there's the y-intercept, there's the slope. The graph is easy. Well, here's a graph, maybe. The y-intercept is negative 4, and when we move over 1, we go up 2. When we move over 1, we go up 2. Over 1, we go up 2. So this is a fairly quick view of things. Here's the same thing, y equals mx plus b. And I've got it set up so I can play with the slope. And if the slope changes and goes up to 4, then when I go from the curve, point on the line, if I go over 1, I'm going to go up 4. 1, 2, 3, 4. Any point on the line, if you go over 1, you go up 4. 2, 3, 4. So this is what the slope is telling us. The b, if I plug in 0, 0x is just 0, sorry, 0m is just 0, plus b, so whatever the b value is, 1, is going to be the y-intercept. And if we change b, the line looks like it's sliding. It's basically just going up. If we have b is equal to 3, then the y-intercept is 3, and there it is. In this case, the slope is 4. If we move over 1, we're going to go up or down 4. So let's go with a particular example of this. If you want to make a complete graph of y equals 1/2 x minus 3, the important features of the graph are staring at us. This minus 3 is what we get when we plug in x equals 0. It's the y-intercept. So we go down on the y-axis to negative 3. The x-axis, y-axis. We go down to negative 3. And then the slope is 1/2. So if we go over 1, we go up 1/2. If we go over another 1, we go up 1/2. Or, thought another way, if we go up 1, we go over 2. Up 1 over 2. Up 1 over 2. And what's nice about this is you can quickly move along on the slope and just make a very accurate set of points for whatever part of the axis you're looking at. And then you can get out your ruler and draw yourself a line, and you can do a very accurate drawing in a hurry. Now, the complete graph for our class labels the y-intercept. So when I plugged in 0, I got minus 3. It also labels the x-intercept, where is it across the x-axis. Well, in this case, we can count 1, 2, 3, 4, 5, 6. So that's the point. X equals 6. We moved over 6. We didn't move up or down, so it's 6, 0. But we can also do that algebraically. We get the x-intercept when y equals 0. So we plug in y equals 0, and 0 equals 1/2 x minus 3. So 1/2 x equals 3, or multiply both sides by 2, x equals 6. So I plug in y equals 0, like there, I get x equals 6. And there's the complete graph. It has the x-intercepts labeled, and it has the slope, and everything's nice and neat, and you have the ruler, and you've got a good graph. Now, you should be able to do a quick sketch graph, and to do a sketch graph, I'm going to do it without the graph paper. Just a quick sketch graph. Y equals, let's try negative 2x plus 10. Just a quick hand graph says, okay, this is going to be up at y-intercept of 10. There's 10. I'm going to label that 0, 10. The slope is negative 2. When I go over 1, it goes down 2. Over 1, down 2. And whatever units you want to use. So I'm just going to say that's about the slope of minus 2. It's falling. And now, even with a sketch graph, I'm interested in what is that x-intercept. So I can easily say, well, when y equals 0, then I get minus 2x plus 10. So 2x equals 10, and x equals 5. So this is the point 5, 0. And you can check, does 5, 0 work? Well, back up here, minus 2 times 5 is 10, negative 10 plus 10 is 0. Yes, it works. Does this point work? When I plug in 0, I get 10. If 2 points on a line work, then you have an accurate graph. Now we could say, oh, I went down 10, and I went over 5, so the slope is negative 10 over 5, which is negative 2, and of course that matches up with the slope we have there. Okay, that's the idea of y equals mx plus b. It's something you can work very quickly, make a quick, very accurate graph, if you have it in that form. Right, good for now.